वही है।
हाँ,
ये क्रिटिकल मीटिंग कहाँ पे, ये तो सुना है। No, ma'am, you're not getting.
അംഗം വിസംഗം വരുന്നില്ല. ആ ലൈറ്റാ വന്നത് ബസർ വോയിസ്. ഓ അവര് വോയിസ്. ആ
the we have done over a period of time, where we and what is the future of electric traction. It was exactly 100 years ago, in the year 1925, February 3rd, first electric train ran between Bombay VT to Kurla on Harbour Line in Central Railway for about 9.5 miles. Railway 2 has a unique history of running first electric train on MG traction. First EMU was run in 1931 between Tambaram to Madras Beach. Sir, 100-year celebrations are taking place all over Indian Railways. In the divisions, exhibitions, rallies, quiz competition, so many things are being done to spread awareness about electric traction and its benefits. At Jonan Railway, also in Southern Railway, we have conducted one exhibition on 1st February at Rail House, attended by all DRMs of various division and headquarter officers. A walkathon was also organized at Rail House on 3rd February. Further, at Railway Board level, on March 7th, international conference is going to be organized, which is likely to be attended by Prime Minister of India. During the function, a stamp and one coin also are going to be released. Many technical seminar papers will be presented. Now I request Sri Somesh Kumar, PCW sir, to give his welcoming address.
Good afternoon, respected GM sir, colleague PHODs, HODs, my colleague officers, ladies and gentlemen. A very warm welcome to this technical seminar on the occasion of centenary celebration of railway electrification in Indian Railways. As Indian Railways achieved the centenary of its electric train on February 3, 2025, it is an opportune moment to reflect on the extensive history, significant milestones, and transformative achievements that defined a century of electrification. This journey from the inaugural run between Chhatrapati Shivaji Terminus and Kurla in Mumbai to the brink of complete electrification of broad gauge network of Indian Railway encapsulates a narrative of technological innovation, infrastructure development, and a steadfast commitment to sustainability. The advent of railways in India commenced on April 16, 1853, with the first passenger train journey from Bombay to Thane. However, the transition to electric traction was a gradual process. Globally, the first electric passenger train was introduced in Germany in 1879 by Werner von Siemens. It took India an additional 46 years to embrace this technology, culminating in the inaugural run of electric February 3, 1925. This 16-kilometer run from CSMT to Kurla utilized 1500-volt DC system, marking India's entry into the electric rail transport. This development positioned India as the 24th country worldwide and the third in Asia to operate electric traction in railways. The initial adoption of electric traction in India met with several challenges. The high capital expenditure required for electrification posed a significant barrier. However, the advantage of electric locomotives, such as superior power, rapid acceleration, reduced maintenance, and absence of direct emissions, became increasingly evident. These benefits were particularly pronounced in urban centers like Mumbai, where dense commuter traffic and steep gradient highlighted the limitations of steam locomotives. In 1904, W.H. White, the chief engineer of Bombay Presidency government, proposed the electrification of GIP Railway, Great Indian Peninsula Railway, and Bombay, Baroda and Central India Railway, BBNCI, now known as Central and Western Railway. And the proposal was sanctioned for electrification on these two routes, setting the stage for future developments. Following Mumbai's pioneering efforts, the Southern Railway, Southern Indian, also known as SIR, initiated the electrification of its suburban network. The Madras Beach to Tambaram line was electrified using the 1500 volt DC system, with completion achieved by 1931. Notably, this section remains one of the few meter gauge sections ever electrified in India. By the time of India's independence in 1947, approximately 388 kilometers of rail lines had been electrified, primarily concentrated around Mumbai and Madras. In eastern India, the journey towards electrification faced delays due to disruptions caused by world wars and Great Depression. It was not until the 1950s that significant progress was made. A 1954 report by a railway team studying European electrification models recommended the adoption of 3000 volt DC system for the region. The first electrified section between Howrah and Shiorah-Phulli was inaugurated in December 1957. Concurrently, France's SNCF developed a new 25 kV AC system. 25 kV AC system was first used in Bardhaman Mughalsarai section in 1957, followed by Tatanagar and Rourkela section. The first actual train was run with 25 kV AC traction on December 15, 1959 in Kondai-Pesi Rajkharwa Sawas section of Southeastern Railway. The success of this trial made Indian Railways to adopt the 25 kV AC system and as the standard for electrification in December 1959, making India only the second country after the Soviet Union to implement this system. The subsequent decades witnessed a significant acceleration in electrification. By 1966, electric traction accounted for more than half of the freight traffic in Eastern and Southeastern railways. Electrification also expanded rapidly in suburban networks, notably in Howrah, Sialda, and Kharagpur divisions. In current regime, the electrification pace has further picked up, and as on October 20, 2024, Indian Railways had electrified 61,687 route kilometers, almost 94.9% of its broad gauge network. This achievement underscores the government's commitment to achieving 100% electrification by December 2025, aligning with its net zero carbon emission target by 2030. Modern train service like Vande Bharat Express have emerged as a result, offering faster, energy efficient and comfortable travel options. Today's India's railway electrification success is unparalleled, with the country now home to the world's biggest electrified rail network. The only remaining non-electrified lines are some heritage and mountain routes. As Indian Railways celebrates the centenary of electric traction in 2025, it is poised to reach new heights. This was a brief about the journey so far, and this journey will continue. On this occasion, we have done many more other activities. This technical seminar is one of the activities carried on this occasion. I'm very thankful to GM sir for taking time out from his busy schedule and attending this seminar. I'm also thankful to my fellow colleague PhDs who have joined us here. A very warm welcome to all of you, and we hope that we'll have a very fruitful technical session. Thank you very much. Jai Hind.
Thank you very much, sir. It was a wonderful narration. We could see the total how the electric traction evolved over 100 years. I request now for release of one leaflet. I request GM sir to release this. Sir, this is basically, it gives the complete picture how electric traction evolved over the years and the present scenario and various developments in modern technology and what is the future. We just try to compile everything, sir. Now, I request GM sir to give a keynote address, sir.
Dear colleagues, officers, supervisors, staff, ladies and gentlemen, good afternoon to all of you. At the outset, I would like to congratulate all of you for the centenary celebration for electrified train journey, which started on 3rd February 1925, and entire history has been narrated beautifully by PCEE Saab. And it is very fascinating to know and very, I would say, satisfying to learn that whatever technology we adopted over the years, primarily 25 kV traction. That time, not many countries had already switched over to 25 kV, and there must have been a lot of debate whether to adopt 3000 volt DC or 25 kV AC traction. And Indian Railways took a very wise decision to adopt 25 kV system, which today I believe, as I was discussing, has been adopted and being utilized by majority of the railways, maybe 90% plus, including Russia and erstwhile CIS countries. So that itself shows the prudence of our predecessors. In Southern Railway, as you've heard, first EMU train service was run between Beach and Tambaram way back in 1931, almost again 100 years back. So we have been progressing on the path of electrification as much as any other zonal railway. So by now, almost 100% electrification has already been achieved on Indian Railways, and all the basic technologies are well established, whether they are traction system or transmission system, voltage, substations, TSS or SSPs, SPs. Most of the designs are almost like frozen. Now we are upgrading to 2 into 25 also. What further we need to achieve is the energy efficiency and energy saving. How much, energy efficient we can make our entire system, which includes right from receiving the high voltage energy from different power producers and then bring it to our TSS, converting it efficiently into 25 kV, then feeding it into the grid and our OHE system, then utilizing efficiently by our locomotives. So it's a complete system, right from, from energy production at some power plant or the power grid, national grid, and then tapping that energy and right up to its utilization, conversion into traction. So now in future, more and more focus would be on how much energy we can save. So our focus should be on that, as well as we have SCADA in every railway, in every division, which can be utilized not only to remotely control the operations from the control room, but it also acquires a lot of data in the process. So it's high time that we must use that data, because millions of data parameters are being collected every day, but it has to be at the back end analyzed and utilized for the two main purposes. One is to make failure predictions, so that we have already discussed with PCEE, we should develop a machine learning based algorithm which will collect all the data of a division, analyze it, and then simulate, means match it with the past failures data at when some failure occurred in the grid, and what were the parameters? What was the parameters which were existing right before the failure? And if those type of parameters are again being recorded by the system, so it can predict failure is imminent, and you can take action to preempt that failure. So that is one area where a lot of work needs to be done. Perhaps World Railways might have done. I think Indian Railways, we are yet to use that system. In S&T also, signaling also, we are trying to develop such type of systems. Then other area is the energy, improving our energy efficiency, right from, receiving the high voltage electric current into our TSS. That all technology, lot of technology is in the developing stage, lot of technology is already established. We have also started adopting various measures so to achieve more and more energy efficiency, like energy storage devices, both for your TSS as well as onboard, including the battery, where the regenerative braking system energy can be either fed into the grid, or it can be stored on board, or it can be stored into the substation itself. And there is a concept of reversible substations, which can not only feed into the grid, which can receive from the grid and store the energy. And at the time when there is peak energy, that stored energy can be fed into the system. So all these areas are new areas, capacitor banks, power factor enhancement equipments. A lot of research is going on into that. So my advice, or I will urge that all of you should work on those areas so that we can save more and more energy, and we can make our locos and traction system more and more energy efficient. Plus, we are also now generating a lot of renewable energy in the form of solar as well as wind, and which, electric traction has that flexibility of, all type energy can be fed into the grid. So that is such a good system, because it's not an isolated system like diesel locomotive or steam locomotive. So in various sections, the imbalance in the consumption can be adjusted either through transferring energy from this section to that section, or by, if it is a net access, that can be stored temporarily in the capacitor banks or in the energy saving device, and again can be fed into the system. So that with that type of flexibility, if we further enhance our efficiency, then a lot of energy can be saved further. So we should, means zonal railway is big enough for making these experiments. We should try to do many such experiments, which ultimately, whichever are proven successful, can be proliferated, not only in Southern Railway, but all over Indian Railways. Thank you.
Thank you very much, GM sir. You have really given the challenges which electrical department is facing, especially the energy conservation in the total system, and also data analytics to improve the reliability of the system. Definitely, sir, all electrical officers are here. We will work on those lines in the coming days, coming years. We'll definitely achieve, good reliability and energy conservation in the coming years, sir. Now, I request PC sir to give one small heritage model to GM sir, which we have the initial loco. It is the initial class of locomotive, sir, made by Raipuram Shed, sir. Sir, now it is the time for us to start the presentation. I request the GM sir and PC sir to occupy the chairs below. Then we'll lower the screen and start the presentation, sir. Chairs. Yes. The first presentation is by Sri N. Balaji, CLE Southern Railway. Presentation is on real-time predictive analysis of three-phase locomotives. Screen milega. Screen will be there.
Respected GM sir, respected PC sir, other PHODs, officers, and supervisors and staff. Good afternoon to all of you. First of all, I express my deepest thanks and gratitude to our respected GM sir for giving me the opportunity to present a small technical paper on this esteemed podium. Sir, this is our this project. This is a small paper we have started after sir has visited on that day exhibition and thrown as a challenge that if it is RMS and RTAs, why can't you do data? You can take out the data and analysis and predict for a failure. So we took it as a challenge in these 4-5 days, and we have come out with a solution, and that we have discussed with our vendor also, and we have come out some success. We got some success. So first of all, for that, I express my thanks to our GM sir for having this light idea sparked in our mind. So next, sir, first I'll start with the presentation. This is our loco, where this is our three-phase loco, where the data is available here. Sir. This is our data. Monitor. Sir, this is our loco, sir. Now in this logo, whenever it comes to the shed, we have to download the data. And the data, our limitations are, data is huge. Logo will come to shed in 90 days only. Online checking of real data is not possible. So you have to download the data, analyze in each and every point, and then only we can come to the conclusion. So this is our difficulty. Now, next, we have developed this RMS and RTAS. On that day, sir, as I have this thing, this RMS is a remote monitoring system, which CLW is doing, implementing in locos, and we have got 13 locomotives RMS system. And this is a real-time information system where is being developed by the CRIS for locating the real-time loco information. So this RMS system, this is the server available in Visakhapatnam. This server, and from the shed they have given a one user interface. We can find out certain data from this user interface. Similarly, from the RTAs also, this server is at the CRIS. The information, all the information from the GPS, where the loco is standing, it all go to the server. And from this server, we can see from the shed, and the same data is only going to our CO, that passenger information system, that where we can find out this COIS. So now this is the data available in the RMS and RTAS. This is a remote monitoring system. This is a real-time data from the various sensors. This is a fault diagnostic data also from, this is a loco. So both real-time data, fault diagnostics is available in this format, sir. This we can see it from the shed. And this is the RTIS system, where the current location and the train details, source and destination, etc. These are all also available, and that is available in this format. Both are given on dashboard in that. Now our challenge is to take out this data from these both and analyze. So these are the bottlenecks. As I told, manual checking is very difficult, and alert. This is the main thing for failures. So all the failure data are available in the loco. These are all called as a P1 false and P2 false. Both our loco failure are related with P1 and P2, and they are all available in the loco. So these P2 messages will go unnoticed, as LP will acknowledge and work the loco without any action, but they have a very important impact on the reliability of the locomotive. So immediately the P2 message will come. After some time, the loco will fail. So we will not know what has happened. This is the now present analysis. And here also is the immediate and quick analysis of loco faults, and alerting the TLC is not possible due to above bottlenecks. So now this is the to solve this business problem. As per GM instruction, we are made one small algorithm. So we will collect the data from the RMS and RTAS, and this is the logic domain to identify the faults. So this is the domain logic. So where for every problem we have to develop, and this is the implementation of software by the vendor, and the decision making will be done by the software, and we can know where is the location. Sir. Yes. So further 10 more locomotives CLW has given this thing, sir. Sir, it is a pink book sanction, sir. RSP sanctions. Sir. The CLW, it is a board centralizedly they are procuring for all the railways. We can propose. Yes, sir. We can install, sir. Yes, sir. And he comes to here, sir. They come to here. They come to loco shed. They only CLW give only the order, sir. They will come and install here only. Sir. 2-3 vendors are available, but centrally they only give the contract, sir. CLW. So then we took out the two business problems which bother us more, sir, nowadays. One is this life-saving missing of cords and tripping. Another one is this axle lock, sir. So this life-saving missing means this cord failure inside. So cord we have got redundancy. If one cord fails, another it will take over. But the future it will fail immediately. So we are not able to identify exactly on a real-time basis. We are not able to take out the locomotive. And this axle lock cases also immediately straight away it is getting axle lock. So for us also we have to find out so many data may be available. We started analyzing the DDU data and the VCU data. As regarding the axle lock cases, sir, we have got P2 fault messages. There are triggers available as a speed disturbance, TM isolation, temperature more than the limit, TE bar BE reduction. So these are whenever the speed difference is more than 10% of, if two axles are having the speed more than 10%, the speed disturbance will come. Automatically, similarly, when the temperature more than the certain limit, TM gets isolated automatically. Driver will only acknowledge, we will not know at all. And then similarly, tractive brake effect also it will reduce without any much trouble to loco driver as well as for us. But this can happen due to speed sensor defective as well as real axle lock. So we have to differentiate the difference between, we have to differentiate whenever when this trigger happens, we have to differentiate whether speed sensor is defective or the axle is getting locked. So we have developed an algorithm. We went through we took the data from the 50 locomotives of axle lock, and we took the data of the speed sensor defective cases also. So we analyzed it. So this is the RMS data, sir. So these are the data, these triggers, we found out that it is available in RMS data. Speed disturbance, TM isolation, temperature more than power reduction. And then here also temperature also available in the RMS data. So with this, we have to analyze and then come to conclusion whether it is a real axle lock or it is a sensor defect. When it happens, then we have to take their location from RTAS, and then we will be sending the alert through SMS, Telegram or WhatsApp to the concerned TLC to stop the locomotive, as well as to alert the home shed to know the present what is happening. Sir, that is this logic is before axle lock. So that is what, sir. Whenever the temperature, when the temperature is getting more. Yes, sir. See, in one cases, 2 hours before, sir. 2 hours, approximately 2 hours, 3 days. Sometimes 1 day before also we got, sir, in one case. So yeah, we analyzed 15 locos. In one case, we took about 2.5 to 3 hours before. And then one case, one day before itself, this is giving signal. So we can, instead of, if we get it, we can stop in the station. No, sir, this logic we have developed. Now we have come to the soft algorithm. We have to develop into the software, sir. So this is the roadmap we took arrive at the logic, sir. We took the fault and messages of more than 15 locos, sir. And then we analyzed each and every data. And then case study also we made the fault similar triggers because the same triggers are shown for all the so many other failures also. Then we have to identify the whether from the real failure which is false failures. Then immediately which is the real cause, and then logic is to be implemented, sir. So this for example. So this is a 139054 case, sir. So actually this is the loco data, sir. This loco data only we are taking. Loco data will be available like this, sir. So this is the temperature difference more than limit. Then this is a TEB. This has happened in 2338, sir. And then axle lock happened about 2 o'clock, sir, actually. 2 o'clock in this case. So there is a difference between about 2 hours difference is there, sir. Sir, now only we have developed. Sir. Look. It's very less, sir. Actually, so इस साल suddenly increase हो गया, sir, actually. Yes, sir. ठीक है सर, ठीक है, ठीक है.
Then you will get to last 3 years.
Sir.
No data for last 3 years.
Last data 90 days is only how many? 3 years data is available. 90 days. 180 days. 180 days. Certain locos are having 180 or 90 days only, sir. 3 years data is not.
Software you are saying.
Yes, sir. RMS, sir.
Yes, sir. Data is available only for 6 months.
6 months, sir.
For that you can't.
You can't analyze.
Sir.
It has been wiped off, sir. We have not checked up that aspect, sir. I will check up that aspect. Sir.
What kind of failure?
ठीक है, sir.
All those actual logs occurred over last 3 years.
Sir.
Suppose how many cases?
Last axle lock. Last June onwards, it is there, sir. About 10, last June onwards, about 10 to 11 cases are there. Yes, sir. 15 cases are there. Including E-Road and Raipuram, 15 cases are.
Go for 3 years.
Sir.
It will be like 50 cases.
Not much, sir. Previously, last 1 year only these axle lock cases are more, sir. Previously, it was not.
Maximum.
Sir.
So you are able to fetch all those 50 cases. Thank you. Board of critical reading.
Sir.
Relevant for Excel.
Axle lock. Yes, sir.
How many readings are relevant?
There are only 4, sir. Only speed, temperature, traction motor isolation, and TEBE reduction. 4 only relevant, sir. Other data is no, sir. Other data is not relevant because concern TM only axle lock, sir. Concern TM के लिए इतना ही है, sir, sensor. Sir.
Lot of sensors which are relevant to Excel.
Yes, sir.
Only 4.
4, yes, sir. That trigger. Yes, sir.
Install 2-3 more times.
Yes, sir. We.
Relevant.
Yes, sir. Yes, sir. We are vibration measurement or some other one more temperature. Yes, sir. We'd like to do.
And you know, it, higher messages.
Yeah. Yes, sir. Yes, sir.
It will think on those.
ठीक है, sir.
Just depend on RMS.
ठीक है, sir.
If you think you need to install additional sensors, then you should retrofit additional sensors.
Yes, sir. But now from this our present experience, sir, now itself we are coming to some 75% accuracy ki we are coming, sir. Yes, sir. ठीक है, sir.
You have to go back to all the past failures.
ठीक है, sir.
In study, that during, up to 4 hours before that study,
Yes, sir.
up to 12 hours before that, what was the pattern of various parameters?
Yes, sir. ठीक है, sir.
4 or 5, are being captured, but 2 things want to capture, but you don't have.
Yes.
All the sensors also you can.
ठीक है, sir.
Then combined, reading of all those things to indicate.
ठीक है, sir. So
This
this
is the communicating first to the server through what? RMS.
RMS through GSM, it is having on GSM 4G SIM is inside, sir. With that it will go, sir.
Will go to
Disha, there is one server for this firm is there, sir. There is firm is called Lotus, sir. That they have server at Visakhapatnam. From there it will go. They are, I think.
for entire Indian business.
Yes, the zonal relay को होना चाहिए, sir. They have also pilot में they are running, sir. They may transfer to Chris, sir, soon, I think so. Chris, no, sir, they are transfer the server. Chris का server को they may use, sir, now. And I think it is in the process.
Control room में
ठीक है, sir.
any issue is where to install the sensor or to
Capture the data, sir.
sensor to your server.
ठीक है,
Server to your algorithm.
ठीक है, sir.
That algorithm should offer like all the data
Yes,
from different sensors. Therefore, let us install 50 sensors.
yes, sir.
So 24/7 the data will be fed into the server.
Server, sir.
Whenever a combination of value
Sir.
it indicate minute pay.
ठीक,
That time it will generate the alert of that particular process. That should be the
ठीक है, sir.
logic.
ठीक है, sir.
इसमें तुम्हारे कोई server is not important. रोबोट को आप अपने घर पर रखो।
घर पर उसको कम्युनिकेशन कर लोकेशन आता सर ठीक है सर
Important much about transmitting the data.
ट्रांसमिट ठीक है सर ठीक है सर
Too many sensors, which location sensor are to be installed, and what parameters are to be put.
ठीक है सर आई विल एनालाइज
Algorithm for analyzing those parameters.
ठीक है सर ठीक है सर
Many.
ठीक है सर ओके सर विल डेवलप सर so this is the CDAC backend sir this is CDAC backend this is a logo information available here sir so if it is a TEB reduction then we can find out the temperature sir further this is the temperature available sir TM1 and TM2 TM3 this 84 degrees centigrade 72 and 61 sir so this is the temperature with that we can come to conclusion these are the various data sir digital and analog input now further if you say this sir temperature more than the limit if we can click like this and here we see that this is temperature is 122 degrees centigrade so the difference in temperature between TM2 and TM1 is more so this is with this we have to take it out for analysis purpose sir so whenever such thing happens so with this we can find out when temperature is more now so whether sometimes this temperature more is due to this sensor defect also sir so for the sensor defect we have taken one sample case as 30539 similarly the same type of trigger will come but the temperature will go down sir that I will show sir this one this is the so many digital inputs sir for this from the data here the temperature is there 78.9 86 and motor temperature is coming sir
Manually.
ये सब ये this is the difficult sir ये सब manual नहीं होगा ना सर इसके लिए सॉफ्टवेयर चाहिए this what हाँ हाँ yes sir next next slide
From these five sensors, it's going beyond, specific value,
yes sir
and it indicates this.
yes sir
So, so लॉक से कोई मतलब नहीं हमारे सॉफ्टवेयर तो ये तो आप एक कह दोगे तो ये लॉजिक है तो ये लॉजिक है वो आप विल नो दैट इज द लॉ ऑफ समथिंग तो डेवलपर को यू हैव टू बी एंरोल
ठीक है सर
फॉर ईच
ठीक है सर
where to
that logic has domain logic has to be
and then which value of the sensors or combination of sensors indicate what type of feedback.
ठीक है सर
That you have to tell.
okay sir
Then he will put the machine learning based on the future
ठीक है सर
false prediction here. Suppose you have built into the algorithm values of sensors to indicate and it generated rather but Excel log did not have all of it.
yes sir false sir
Some deficiencies of
algorithm
so that once you read the data for that particular the algorithm should correct itself.
okay sir algorithm should correct it yes sir
Itself,
ठीक है sir
not then the
once again we have
no required.
no more record ठीक है sir so this is the second logic sir we made it for that life sign missing is card defect sir so in this one this is the rectifier burr and subsystem isolation sir but it will not fail so but then this card failure can be transient or permanent sir transient means attention on arrival and information to home shed can be given and if it is permanent it will go to the nearest shed and home shed this also we have developed this
So defect.
sir
Is the cause.
sir
You have to validate this algorithm against those things.
ठीक है sir
This might be one or two things. How many things?
it's a previous history of about कितना failures 20
It's more than 20.
20 failures we have taken sir 200 ठीक है sir
That Logic should not fail for others. When you validate it against the different various which have not been incorporated.
ठीक है सर,
Validation होगा.
ठीक है सर, होता है करता हूँ. ठीक है सर. Yes sir, that's why we are done, sir. So this is the various data, sir. This type of data where the life sign missing cases is FLG1 will give ki FLG2 sign is missing, but it will manage. Similarly, FLG1 also will say ki life sign from FLG2 is also missing, but it also managing in going on. So, but then it will fail next, then before next trip it may fail, or after some time also it will fail. We don't know when it will fail. So such things we are finding out, and then
Informatory alert should not.
okay. Oh,
Informatory alert होता है always पापा मेरा manding हो एयरपोर्ट पहुंच गया वेटर मिनिस्टर पहुंच गया फिर आप क्या एक्शन कुछ लेंगे
नहीं sir.
नहीं कर मुझे तो बताते रहना
ठीक.
लैंड कब किए एयरपोर्ट से बाहर कब निकले ऐप कब ली सर्विस कब पहुंचे तो वहां से जो है कब लिया एक्सेसिव कंट्रोल.
ठीक है सर.
Just all that data is used garbage.
ठीक है सर.
Polluting or without any information.
ठीक है.
Garbage in, garbage out. दूसरा information है कि he will call only when he stuck up.
Stuck up. Okay.
So flight cancel हो गई. So I have to take next flight. Which is the next flight I should take.
ठीक है सर.
Need guidance. That is the alert.
ठीक है सर.
So वो informatory alert की जरूरत नहीं.
ठीक है सर.
Otherwise, the chat will be flooded with so much of information.
ओके सर.
उसको देखना ही बोलेगा फिर से वो मुझे आराम बजाता रहता है आराम ही बंद.
ठीक है.
One should be yellow alert. That should also be actionable. Other should be red alert. Immediate action.
ठीक है सर.
No third type of alert.
ठीक है सर. So this is the some logic we have made, sir. This Droco data ko through RMS we are taking and analyzing, and like this we will implement the learning also here, and then we can give either alert message to.
So RMS data, it is going only to that server. Why can't you take it to your server?
Okay, sir. I'll take, sir. We will take, sir.
The data is there for
Sir.
any server.
हाँ, yes, sir. ठीक है, sir.
वो जो सेंसर लगा रहे हैं आप लगा दो.
ठीक है, sir.
उसका क्या है उसको?
नहीं, sir. Will come only communication will be there, sir.
और क्या है?
And that is all available. Loco data only loco में available है, sir. RMS is only just giving the communication, sir.
Vibration sensor.
ठीक है, sir. Okay, sir.
Vibration acoustic.
ठीक है, sir. ठीक.
What I am saying, I think can be implemented in 2-3 months for all 600 loco में लगा.
ठीक है, sir. We'll try.
So by now it is established, no? How many sensor and what type of sensor are to be installed where? Or this is also a matter of physics.
That is also we have to, for Axilla cases, we are still in research. No, FAG is coming, sir, to us next week. So he's coming to us. So with this, we will study.
वो आ रहा है जा रहा है उसको तुम्हारे इससे क्या लेना देना है?
Vibration sensor से लगा.
That basically existing sensors हैं, say
Predictive होगा.
Vibration sensor and acoustic sensor.
So that extra sensor, sir, has talked about something.
Temperature sensor.
Temperature इधर ही है, sir. Temperature है, sir. Temperature available.
ये बात आगे तुम्हें बता देगा टेम्परेचर नापो तो आप बोलोगे टाइप वाले ने बताया वो तो मार्केटिंग वाले होते हैं. What type of people are?
ठीक है, sir. Technical people only, sir.
चेक कर लेना.
ठीक है, चेक कर लेते हैं. और नहीं है तो हम लोग कर लेंगे, सर. नहीं तो हम ही लोग कर लेंगे, सर. ठीक है, सर.
तो बियरिंग की कंपनी वाला है.
ठीक है, सर.
अभी तो बियरिंग बनते हैं इंडिया में.
यस सर, हाँ ये इंडिया में बनता है सर, ठीक है।
और भी तो बिजली बेनिफिट है।
यस, SKFD है सर। So this is the mainly temperature, sir. Yes, sir.
On the other side, so
Temperature, sir, mainly temperature, sir. And
Vibration sensor additionally there
acoustic beacon.
and acoustic.
नहीं होगा।
नहीं सर,
एक कमरे में जाइए,
ठीक है सर,
सेवा बताएंगे।
ठीक है सर।
That's all.
थैंक यू सर।
तो प्रोफेशनल लेवल
ठीक है, ठीक है सर।
वाला बच्चा करता तो उनसे
थैंक यू सर।
Thank you very much, Balaji. It's a good effort in very short time. Now we have presentation on battery energy storage systems from Delta Electronics. They have made presentation keeping in view of the future trends in storage of energy, solar systems and traction systems. In traction substations, we have made a study along with them. We found that we can substantially reduce the CMD, sir. If you put 6 MVA, around 4 MVA, at least we can reduce and make huge savings. So they will give the details. Please, Vivek Bhatt.
Good afternoon, respected GM sir, Honorable Principal CE sir, and all the senior delegates and officers of the railways. So first of all, would like to thank you for giving this opportunity to give the seminar or the presentation on battery energy storage. So first I would like to introduce myself. My name is Vivek Bhatt. I am a director in Delta Electronics India, looking after the activity of the battery energy storage and power quality, co-working with Southern Railway from quite a few years, and in the industry for more than 20 years. So maybe. No, next slide. So we'll give the brief, start with the brief introduction of battery energy storage. As a part of that, we'll also cover a case study, what we did it for one of the substations to check what will be the maximum demand reduction and other things we can do using the battery energy storage. So yeah, this is the energy storage introduction, a small brief. So what is energy? We know everyone. So storage is just we store it and we reuse it whenever we require. So this is what is a simple concept what we all know as a basics. But now due to the advancement in the chemistry cells and also the cells are now smart, wherein even the battery can communicate. So we will be able to discharge and charge based on our need. So keeping that in mind, just to give an example now, India is going for 500 gigawatt of renewable energy. That is the target what we have for till 2030. So keeping that in mind, we can see as more and more renewable comes into picture, this is how the generation curve comes if we consider it as more of a solar generated energy. And whereas
the load will vary. So the idea is, if we consider this as an nominal load curve, then we have to store this excess energy which generates in the day, and we have to discharge in the morning hours and discharge in the evening hours. So this is one simple concept how we can store the energy. And finally, the output grid, something like that, to meet the load. This is the concept. So capture for use at a later time. That is the fundamental idea of energy storage in simple terms. Sorry. For this, we have different energy storage technologies: mechanical energy storage, electrochemical energy storage, thermal storage, and others. The mechanical energy storage includes pumped hydro, flywheel energy storage, compressed energy, air energy. All these are some of the energy storage. Some of them are there from long. The electrochemical energy storage, where is the lithium ion energy storage now, which we are predominantly talking. The lead acid battery energy, sodium sulfur batteries, flow batteries. Here also we have multiple options. Thermal storage, phase change materials, ice storage, molten salt, hydrogen as an storage application, I mean to source, supercapacitor and hybrid storage.
But capacitor also is used somewhere.
Supercapacitors can be used especially for fast discharge time of applications, where suppose the grid dip happens for very short duration, say because of some fault at the distance, then there will be a dip of say 30 millisecond and other things. At that time, the supercapacitors can be used where fast discharge applications can be developed. Now it is in a very nascent stage for large applications, but supercapacitors will come eventually. Now already it is available in the market, but economically not yet so much viable. Yes, sir. So this is a brief snapshot of all different storage technologies, and you can see here different compared against different parameters. So I don't want to go it in detail, but I would like to quickly take it to the last column, where we can see here if you compare all the parameters, the lithium ion technology is the one which is either above the average or it is the best. It is not at all coming low. For example, if you consider the other technology, for example, flywheel technology, the long-term storage is very low. Whereas if you say lithium ion, it is moderate. So in all parameter, if we see the efficiency wise, it is high, and power density is high. The energy density, cycle life, which is moderate, but still it is considerable. So keeping all these things in mind, for storage technology, lithium ion is one of the best technology available right now. Now comes the in detail of battery energy storage. So what is battery energy storage? As I told you that we are going to store the energy for later use using the chemistry of batteries. Typical applications are power backup and high capacity lithium ion batteries, sophisticated inverters, and intelligent energy management software. With this, we are going to have an application which enables business to store surplus electricity during periods of low demand, help to reduce operational costs, enhances energy security, reduces carbon footprint. These are some of the benefits. Now let us see the application areas of battery energy storage. The battery energy storage, we can simply divide based on the use cases, the front of the meter and behind the meter. The front of the meter is the one where this is where the generation comes, this is the transmission, and these are the places where we are going to use the energy. So meter comes here. So what all there in front of this, these are all front of the meters, and this is behind the meter. The energy storage energy technology can be used both sides, behind the meter and front of the meter. Here if you see in the generation side, for ancillary services like the frequency correction and the smoothing applications and round the clock power, wherein the solar generates only in the day, whereas we can store and discharge 24 hours. and to ensure that the round the clock power available is there. Peak demand management. This is the application areas are renewable energy plants, generation companies, all those things can use this. Then next comes the transmission and distribution. Here also what happens due to maybe the sometimes, yeah. Sure, sir. Yeah, well, sure. Directly shall I go or?
One slide up, one slide up, one slide up.
Up and down. Yeah. So this is the demand management application where we can see that the energy what is available, we are going to charge from the grid. Simple example, peak shaving or peak demand management, what we call. We can see this is the peak. Based on this, the maximum demand is always considered. If we store the energy when there is no more demand, I mean to say maximum demand is less, we should store the energy in the batteries and we should discharge when there is a peak demand. So this is what is called as the demand management. Using this, the supplement the load beyond sanction demand from BESS during the peak load periods, and we can also save on demand penalties and electrical infra upgradation. So this is one of the applications which we can consider for the TSS to reduce the maximum demand charges. And I will take this directly come to this case study too. So this is the case study what we did. We measured some of the substations data and we collected. What we seen is the average active power requirement and the peak active power requirement. There is a huge difference. And you can see this is the Tambaram data, energy data what we have seen. There is a peak which goes and there is also a period where there are very less load. So if we average it out, so less than 50% is the average load what it comes. So here by looking at this graph itself, we will be able to see that there is a clear case wherein we can store the energy at this period and we should discharge at the peak such that the maximum demand can be reduced. So based on this, we did an analysis and come up with an idea that wherein we can go with an 6 megawatt, 3 megawatt hour battery storage system with single phase converter, which looks something like this as an application where the battery energy storage comes in a container, which is a portable entity. Even PCS can be put inside a container with a single phase transformer can be put to directly 25 kV, wherein it can cater to the load. This is a simple SLD of the concept. Based on that, what we understood is the current tariff charges for excess MD is around 300% and CMD charges are 90%. Peak load charges are from 6 a.m. to 10 a.m. and 6 p.m. to 10 p.m., which is 25% extra. All these things we have considered in the IRR simulation, what we did. So, and based on the current prices, which we did it, the expenditure for implementation of the above system comes approximately rupees 23.69 crores, including GST. For Tamil Nadu region, the IRR is about 17.74 in percentage. And would like to also mention now, based on the latest the government policies and all, definitely the batteries costs and everything may further go down eventually in few months or so. So keeping that in mind, the further enhancements in the prices can be.
launches, substation will be 5.5, so it is very less. But we have to pay for 21 CM, which is very high. That's what, sir. More substation 21 is the CM. We have to pay all the battery. Yes, how much CM
Four.
3. 4 to 5.
Yes.
MVA we can reduce it, sir. CMP, sir. So the bill comes. Huge, sir. The consumption will come. Consumption will come, sir. Will come. Bill में एक part है, एक running है, एक based on the CMP, they are fixed charges. So even once in a month it touches that CMP, we have to pay as well. So those charges will substantially come down. Because our traction load is so much varying. 20% or 30% maybe traction that high. Otherwise it is very difficult. Yes, sir. Basically, bringing down the CFR, because they are checking for the peak demand. जरूरत नहीं है सर। इसको लगाकर मैं और बात करता हूँ। एप्लीकेशन होगी। That is agreed, sir. Even the total power scenario also, everything based on the maximum demand, the billing system is not. That is agreed, sir. Everything substation का भी infrastructure also they charge based on actually every year we have to increase the sales of all the substation. At least we can stop it. Actually.
So how do you charge the super capacity?
Please. Yes.
Super capacitors come with an high discharge. I mean to say there is something called as C rating. Yes, sir.
Those 2 hours, super capacitor is good enough. Battery is required for long-term discharge.
Sir, basically the super capacitor what we generally, which is in the market, it ना क्या है बताता है sir मैं. Yes sir. Yes sir. The discharge rate will be 10C and above. So like that the discharge rate. Here 2C, 3C is sufficient, sir. Sir. Yes, sir.
Basically, super capacitors are used for very short, for a few cycles. No. I'm talking about short duration in the sense the definition of short is slightly different here. Few super capacitors are typically used for few cycles, maybe less than a minute kind of.
Minutes kind
where, the huge power is required. Here, our application is typically maybe about 1 hour, 2 hours is the duration where.
Super capacitors are not.
For long that for the duration of 2 hours and all, they are not suitable. Whereas
your statement, what basis
sir, we discussed with multiple supercapacitor manufacturers also. नहीं sir. We do a thorough study. Sir. Okay. Sir. Yes, sir. Sure.
So what same scenario. Capacitor cannot be utilized for a vacuum system.
we discuss.
What is super capacitor?
Yes, sir.
Between the two.
Super capacitors are not meant for long duration charge discharge, very short duration.
Substation, super capacitor. But over electric substation, started with super capacitors.
Okay.
Who are saying this? We have to establish why it is better than super capacitor.
Okay, sir. Sure, sir. We will.
It's not a better solution.
Sure. Sure, sir. We will share that data. Yes.
Technical background.
Sir.
Technical.
Yes, sir, yeah, techno commercial.
Here we go.
Yes, sir.
Sir.
So we'll do the study and we'll come back to you. It will not be a problem.
It will,
Yeah.
lot of research has gone into.
Right. Agree.
That's right.
How does it compare with the competitor? Life क्या उसकी तो बहुत long life.
Lifelong.
और कैपेसिटर में तो कोई wear and tear होता
सर,
नहीं.
हाँ सर, सही है. वो बात बिल्कुल सही है सर.
बैटरी चेंज करनी पड़ेगी.
नहीं सर. Sir, 12 years, sir. Sir, here you can see. ಆಯ್ತು ಸರ್, ಹೌದು. Sir, shall we continue from the beginning there, right? Where we stopped. ಸರ್, ಎಲ್ಲರಿಗೂ ಗೊತ್ತು ಸರ್, ಅದು ಯಾರು ಏನು ಹೇಳಲ್ಲ ಅಷ್ಟೇ. Quickly. Then right. Thank you.
Thank you very much, Mr. Vivek Bhatt. It was a good presentation. It was giving a lot of information about the battery storage system. Next, I request Mr. Ramanathan, GGM Electrical RVNL Chennai, to give presentation on rigid overhead catenary systems, which is installed at Pamban Bridge, first time in Southern Railway.
Respected PCW, and other HODs, PHODs, my dear colleague officers, ladies and gentlemen. As part of the centenary celebration, I have been asked to give the presentation on the new system which has been used in the Pamban Bridge, which is going to be inaugurated soon as part of the Prime Minister's projects. Just I will touch upon only the ROCS which is provided in the Pamban system. The hope most of us would have seen it either in the YouTube or directly. The bridge is having the two portions. The middle one is the movable portions, and both sides is a fixed one. So the total bridge is around 2.1 kilometer. The middle portion alone is around 72 meters. The OHA has been given with the fit for the 100 kmph, though the train may run at a lower speed. And sir, lift span total weight is 630 metric ton. We kept the contact wire height at 5.8 meters. There is a double track available in the lift span, but we have done energization to the only one track. As of now, it is going to be a single line only. So this ROCS, it's not the new to the Indian Railways, but the first time to the Southern Railway. The name, as I suggest, is a rigid overhead system. No movable portions. So the next slide I'll show you. It's being in so many metros, and then even it's provided in. I want to go there, sir, first. Show you there. Like the same persons are provided in the RRTS, Delhi Meerut, Katra, Dharam, that's around 60 kilometers. Southwestern Railway is having Castle Rock area around 10 or 12 kilometers. Other than that, even Lucknow Metro, DMRC, it's not the totally new to Indian Railways, sir. It's quite common, and these are all provided by only F&F. There are another competitor like Siemens are there. They even provided in some of the location, which I'm not having the details. So it's ROCS is not the totally new to it. It's a existing system only. For Southern Railway, for our system, it's the first time. So there may be a little bit extra knowledge acquiring may be required. So the as I suggested, the fixed OH is provided in the middle portions where the movable bridge is part. The other two sides are the conventional OHE with the regulating arrangements. And the operation will take place with the engagement investment. I'll show that how it is being working there, how it is being provided also in the forthcoming slides. And the fixed this ROCS is having two systems. One we call the fixed OHE, that is the rigid one. Then in both ends there is we call transition arrangement also, which will give the smooth transition from the conventional OHE to the rigid OHE. Some photographs also available. I will just show it to them. This is how the subsectioning of the Pamban Bridge. The left side is the Mandapam when you are going from Madurai. The right side is the Rameshwaram. Though it's similar nature, we made into three elementary sections. The middle one is the vertical lift bridge one, that violet color. Remaining two are both are another two more elementary sections. The construction which they are doing it, the portion between Rameshwaram to Ramanathapuram will just come and join in the OHE in both ends, in the land portions. They need not do any work in the bridge portions. There are 4 BMs are provided. These are the PT indication. There are BMs 372, 73, similarly 74, 75. These BMs only will operate the even in regular. Even as of now, we are given only 2.2 kV since this section is not electrified. While doing the operation of the bridge, with a single click by the bridge operator, all the 4 BMs will operate at a time. Basically, 2 BMs will get open the OHE so that the middle portion where the vertical lift span is there will get completely de-energized. The second BM in each side, like 373 as well as 74, will do the earthing of the system on safer side. So the transition arrangement which is there in the edge will get earthed. Also, not only de-energization for the safety purpose. This is how the cross-conducting of the typical rigid OH will be there. You can see the cross sections. Basically, this acts like a catenary. This is a typical contact wire, which is the same catenary wire, contact wire, which is used in our conventional OH. That is 107 square mm copper conductors, which are inserted through these special tools in the initial infrastructure time. This tool has been provided as a spare to the division also. It just slight, just by fixing in the rail, it gives a slight expansion of the bottom portion, so that this around comes around 14 mm normally. This space may get little bit expand, so that contact wire can be inserted smoothly without any issues. Same thing only followed in the transition system also. This is what the top portion which we have seen. This is a contact wire. This only act like basically this is aluminum extruded copper conductor, which carries even 18 times more than the typical catenary wire capacities in terms of the capacity. If you look at it, like CD sir was questioning when we want for the approval, this capacity of this conductor system is much more than our normal catenary wires. These are into pieces which normally connected with these middle portions, and also having it will not allow the lateral movement. There is a groove in that. Only with the 4 bolts which can be connected, then the whole 72 meter will come into pictures. This is a portion which I was talking about, how the conventional OHE will get terminated before this ones. There are 2 portal arrangements are available in each side. The first portal, the catenary will be terminated, and then only the transition bar will come. This is called transition bar. Here the contact wire alone will be carry forward to the next portal. That also will be taken load by this V arrangement. So no further load will go into that small portion of transition arrangement. So literally it will be free for all kind of load. There is no need to worry about the further any anchoring on that. This is a typical photo which was taken from the field. This is called the transition bar, which is also called part of the ROCS, which is there in the end, in both side end. And also there are 6 cutouts which are made in such a way that it is having a little bit profile in increasing depth, which equalize the weight automatically. This is a portion where the fixed and movable portions being encased and disengaged, which is having 2 different things. One is called the contact plate, another one is the spring plate. This will be connected to the transition bar. This will be connected to the movable portions. Connected means I can show that only the jumper will be connected. This will be rested through the bolt arrangements. Same thing at here also. We can see photographs. This is that spring loaded one. These are movable portions. This right side is a movable portion which will be lifted up. This is the fixed one, transition arrangement, which will be like that only. It will be remaining as a fixed even in the moving time. Here at the bottom, that contact plate is provided. This one. This plate is provided in the fixed one. This is provided in the movable one. The contact plate is simple plate, a copper one with the jumper arrangement. The jumper we can see also here. This is a jumper in the fixed portions. This spring, the movable portion is having a little bit more intricacies. There is a spring arrangement. There are two springs there inside the box arrangement. The box is basically a SS plate, whereas the inside arrangements are all copper conducting elements. I can show you some other pictures, it will be there. Basically, this is possible to adjust. We can have the here a little bit. These are the two bolts which can be adjusted. This is for the adjustment towards the transverse portions. This is for the height adjustment. And these are the jumpers, which is provided part of the spring loaded arrangements. We can see the actual portions. This is a box arrangement. These are the two springs which are available part of that old system, which is fixed in the movable portion of the conductor. This conductor is there. This is the movable portion of the ROCs. This is a fixed one which is coming from the outside. This is a plate which is now photo was taken in the Pamban when the lifted conditions. So this contact plate is part of the fixed OHs. This is the transition arrangement. Transition arrangement is around 6 meters on each side. This may give you a little bit more idea how it is there. Once it comes down, the spring will act like engagement, disengagement. Basically, it gets spring actions and then it will touch upon the plate which is there in the bottom of that. Now it got engaged, basically through the spring actions. So in a nutshell, the operations are done with the single click arrangements. There is no need of any manual need other than just watching the operations. And system also very cumbersome and then simple nature. It doesn't require much maintenance issues as such. Some of the maintenance which was suggested are very few things like check for any burn marks, check the forms, the springs are firmly loaded, in the sense spring should not be in loose conditions. Clean any buildup, calcite, etc. is there if at all. And the jumper has to be seen whether secured properly as well as jumper is intact. Jumper should not be any having contact. Like a typical OHE maintenance only. Other than that, there is no need to worry anything on that. And all the spares and everything of the inside items are readily available with the OEMs, and it is being covered on the part of the AMC also. So the system which is followed is very rigid, and it will not have any issues as such in the Pamban in coming days. And these are some spares and tools which has been handed out to the divisions for that. That's all.
Thank you very much, Ramanathan. It was very much enlightening for most of us on ROCS system. Now I request Mr. Sundareshan, CW Construction, a presentation on future of electric railways.
हेलो चेक लाइट ऑफ कर दीजिए
Good morning, PC. Good afternoon, PC Ripley sir, and other HODs present here, all the officers. It's a great privilege to have a presentation before such an audience, especially at the centenary celebration of electric traction. Without taking much of your time, I'll go forward कि हम लोग भविष्य में क्या expect कर सकते हैं electric traction में. How can we go ahead and see what is there in future for us? We know what are the systems we are having. So let me take you on the journey. This is the history which all of us know, which our PC sir had told us about chronologically. Basically 1879, and now here what India is. From 1959, we have this traction system of 25 kV AC. So let's see where do we go in future. You have not played from that? The WebEx can be minimized. Sorry for the delay. So basically what is there in our present system, जब train एक section से दूसरे section में जाता है, we don't have a continuous transition. We have neutral sections in between. So when we are in one feeding zone, next slide. Put it in slideshow. Yeah. See, the propulsion systems decide what sort of feeding arrangement we need to have. We had the change in the traction system starting from the DC motors. When we had the DC motors initially, because we require high starting torque for our locomotive traction application. Then later on what happened, we had the development in the power electronics, which made the control of induction motor possible by using the direct torque control or controlling the flux in the motor to the desired level, which commonly we understand as BVVF technology. With that, initially we had the switches of GTO. So GTO are very lossy switches, very difficult to turn off. Then the industry got revolutionized when high capacity IGBTs came into picture. And with that IGBT technology, since 2014 onwards, we are having the propulsion system in the locomotives. Now, when we had the traction systems with electronics, that is traction converters instead of our conventional locomotives, then the concept of regenerative braking came into being, and the regenerative braking, the energy generated is fed into the recap. Now, what are the limitations of the current scenario? Like GM sir had told, the current situation has to improve in terms of energy efficiency. We have to integrate renewables. We have to make our system more energy efficient in future. So we can imagine a world when in future, almost all the energy requirement for our traction can be fed through our own system. How we can integrate and how we can expect that if there are multiple trains also in the same feeding section, the voltage regulation is not bad for the last train. आज की डेट में जो हमारा वोल्टेज रेगुलेशन है वो सिग्निफिकेंटली वेरी करता है. Whenever Vande Bharat comes into a system, immediately when it notches up, 562 amperes are drawn. Voltage dips immediately. At the far end of the feeding zone, the voltage dips to 19 kV. Voltage dip का क्या मतलब है? When the voltage dips, immediately the current shoots up. And we are not able to utilize the full potential capacity of the rolling stock which is going, because the rated power is at the rated voltage. जब rated voltage कम हो जाता है available to the rolling stock, then the power which it can deliver also reduces at that point of time. So the dead zones which neutral section cause in between, they cause loss of traction, and this is one of the limitation of the current traction systems. Second is the power quality issues which we have with the rolling stock and the system. क्योंकि हम two phase से single phase करके draw करते हैं, there is a zero sequence. Similarly, grids also have certain issues with our loads, because we are not taking a balanced three-phase load, which any grid likes to have. So like in Kerala, they continuously resist enhancing our CMDs. Now in new substations also, many of the electricity boards have told they won't give connections, and CEA regulations latest, they specify that we cannot unbalance the grid beyond a point. with heavier rolling stocks coming into picture and unbalanced regulations becoming stricter, it's a challenge for us. Now, low utilization of contract maximum demand due to rolling train. Like in suburban section, as in the previous presentation was shown, we shoot at a certain point, then we come down. जो हमारा कॉन्ट्रैक्ट एमडी है सबर्बन में 40% एवरेज यूटिलाइजेशन है, नॉन सबर्बन सेक्शंस व्हिच आर लोडेड आल्सो इट्स ओनली 25 to 30%, और लाइटली लोडेड सेक्शंस में तो और भी कम है. सो इफ यू सी the MD utilization which we are doing is very, very poor. So definitely something has to be done in the area of improving the MD utilization by our stock. Otherwise, down the line, throughout the line, the extra capacity is built in all the PSA equipments to take care of the spikes which happens when a loco notches up in that section. So ये हमारे challenges है. Now let us see how to overcome these. Now I have added this photo, especially for all of us to know and feel proud that Shri Banban Jayant Balinga, he is the person who has revolutionized this whole technology in the world. He is a Chennai-born engineer who graduated from IIT Madras, and he is the person who invented IGBT and is credited with all the technology revolution starting from BLDC fan to power electronics to converters. And as on date, he has been the most, means if you call a person in power electronic industry, father of power electronic industry, we can say is from India. And we are the people, and as a country, as we should know this. So I had just added this for our general information. Now, this is the main slide which I like to discuss. So if we see here, as of now, we have this traction substation, and we are not drawing 3-phase here. We are drawing 2-phase in our system. If we go for 2 into 25 kV system also, where we'll be drawing 3-phase system, we'll have a neutral section here. Similarly, at SPs also, we have neutral section here. So these are the 3 locations where our supply breaks. So now what is required, that we need to have a continuous integration of energy. Why we require continuous integration of energy? यदि यहाँ पे कोई लोको एनर्जी खींच रहा है या रीजनरेट कर रहा है, and if I don't have a locomotive to absorb the regeneration at this point of time, at here, what will happen to that energy? That will go back to the grid, and we don't have a river powers meter here. तो जो एनर्जी यहाँ मेरे लोकोमोटिव ने या EMU स्टॉक ने या किसी ने भी रीजनरेट किया, we are assuming that some other load in that section utilizes that energy. But we don't have any proof whether it has been utilized or it has gone back. World over, the studies have been done. It has been found that we are not in a position with the fragmented feeding zones to utilize the full energy which is regenerated. So there is a need for integration across the neutral sections. But how do we integrate across the neutral sections? हमारे यहाँ दो, because there is a phase shift. जो यहाँ का feed है और यहाँ का feed है, they are not in the same phase. So here again, the power electronics integrators or power conditioners come into picture, where we have a DC link, and here we have a 4-quadrant converter. 4-quadrant means it can feed and it can take either direction. So we integrate these at our switching posts here and also at our traction substations. The traction substation I'll talk separately. So this is the first point where we are integrating the supply at the switching post by having a power conditioner, RPC's railway power conditioner provided at the section post. So at SP, what we are providing here is that suppose we have a train here which is moving, 2-3 trains are there, no train is here. अब यहाँ का train के far end पे voltage dip हो जाएगा. लेकिन अब जैसे यहाँ से हम यदि यहाँ का power feed कर सकते हैं, so the energy requirement of this can be shared by this also. So when the energy requirement is shared, similarly at 2 substations they share the energy, overall voltage fluctuations will reduce. Similarly, जो एक feeding zone में regenerate हो रहा है, that energy can also be used in the other feeding zone. So this makes seamless integration here. And the capacity of these converters, which are to be used a back-to-back converter, it is similar to what converter we have in locomotive. आप यदि locomotive traction converter देखें, it's also a similar architecture only. We have AC at one point, then we have converted it with a back-to-back DC link, and then we have motor at other point, which has 2-way energy transfer. So similarly, the energy transfer can take place from here to here and from here to here. This is one point. Now, second comes very important point, that how do we integrate the renewables with our system? The future is of renewables. And with so much advancement in wind and solar, the potential is enormous. Our 30% of budget is spent in our energy bills of electrical and diesel combined. It is one of the biggest cost to our organization. If we integrate energy in a manner, this 10 kV, you can take it as 11 kV for our system. It's an international presentation slide. So I'll come to this later. So यहाँ पे जो है, we have renewable energy grid system, which is solar. It is feeding the DC bus. This is the DC bus through which the renewable energy is storing. To the DC bus, we are connecting the energy storage system, the batteries, for extra generation to be taken care of. And through this railway power conditioner here, which is connected to the DC bus, we have an isolation transformer here and we are feeding here. So here overall system is integrated, and this DC bus integrates with the 11 kV for LT system also. Like we have our LT systems and they are also significant loads for our system. So they are also integrated with DC bus. So this DC bus acts as a backup power supply for any failure of this three-phase system. It also acts as a buffer arrangement for taking care of the energy requirements in case of any shutdown and for integrating the renewables. So this is the overall system, how the future of electric traction power supply will look like. And this has been implemented. So the basic advantages of this system, I'll just take you through what I have, I think, almost already stated. These are just listed here, these points. So there can be tremendous cost saving, not just in terms of reduction in the CMD, but also by the way, how we can integrate the renewables and make best use of the capacity which is available with the railway system. Now, this is the system which has been implemented in Japan Shinkansen line. And this system has also at some of the Chinese railway, at Shanghai, at Detong, and these are the areas where the system has been implemented. So these are the various references of various journal papers which have been referred to this. Any questions, if you have, can be asked, please. Thank you, sir. I'll go back, sir. Sir, we can do, sir. It is अभी तक हमने proposal बनाया नहीं है, sir. But the same converters are to be integrated in this manner. They have been implemented world over, and I think in high speed जो कर रहे हैं, sir, or in the semi high speed which we have. Nowadays, we are only talking about 2 into 25, nothing beyond it. But these are the emerging technologies and established ones also world over in advanced railways, which can be implemented and used, and they will be tremendously cost saving with integration of energy, and we can make almost traction net zero, not just non-traction net zero. So that will be a big cost saving for us in the days to come. Thank you, sir.
Thank you very much, Sundaresh. It was a wonderful presentation.
Sir.
I think we can think of proposing works in that line, and it's good to know that. Now we are coming to the last presentation of this seminar, presentation on green energy in electric traction. I'll be presenting this. I will talk. Just present it. Sir, this presentation is on green energy. Go back. The green energy in electric traction. I have selected this topic because so far all green energy, whatever solar or wind, we are talking in terms of non-traction. But now the time has come, we have to, in Southern Railway also, we have to integrate these non-renewable energy sources with electric traction to achieve net zero. Next. So, mission net zero carbon emission target for India in general Indian scenario, as per the Paris Agreement 2015, we are supposed to, on all India basis, we have to meet half of the energy demand via renewable energy by 2030. That is the target given for whole India. And for achieving net zero for India, it is 2070. But for Indian Railways, the target for net zero carbon emission is by 2030. I mean, though for India it is 2070, but for railways it is given as 2030 because railways, one of the organization, it was taken that we can achieve net zero because the way railways works. So we are heading towards achieving net zero by 2030. Just let us discuss. Next. So what does it mean for Indian Railways? 100% of energy needs of Indian Railways have to be met by renewable energy sources by 2030. That means we have to develop the sources or borrow the energy so that all our energy needs by 2030, they have to be compensated by renewable energy sources. By 2030, 2930, it is estimated that IR energy demand would go up to 8.2 gigawatts. At the present, it is 3.72. As per the estimate, it is going to 8.2 gigawatts. And this has to be met by development of renewable energy, almost 30 gigawatts by 2030. We have to make it. That is what projected. And Railways is working towards developing 30 gigawatts so that it will be totally net zero by 2030. Next. So, let us discuss where we stand at the present on Indian Railways wise. So right now the total demand is 3.72 gigawatt. So far, it is only 22% on all India basis. We are able to meet from energy renewable sources. So railway is owning 363 megawatt only. And of course, we are also borrowing, especially the zones where there is an open access. We are able to borrow this renewable energy of 468 megawatt. Overall, at the moment, 22% we are having on all India basis. But however, a lot of work is going on, especially to borrow energy through open access in different zones and also develop more renewable energy sources so that in next 5 years we can meet the demand. In case of Southern Railway, we have 195 megawatt. I mean, right now the share is only 8%. Of course, solar rooftop, I mean, we are going in a big way that we'll be discussing next. So what is the overall strategy, how we can achieve the various things? One is 100% electrification of IR network. And this itself, I mean, we will be able to save a lot of carbon emissions. So that first mission is already completed. Now we are 100%, we are on electrification. So we can develop the sources of renewable energy and make it net zero. Next, efficient use of energy electric traction. There are many things which we'll be discussing, three-phase technology, all that, which will improve the efficient usage. Then HOG technology, it is almost complete on all India Railways. So a lot of curtailment of diesel has taken place. And development of non-renewable energy capacity through windmills, land-based solar and solar rooftop, where all the zones are working, including Southern Railway. So the last one is purchase of green energy through long-term open access, which the zones which are having they have open access, they are able to do it. Southern Railway is not able to do it. Next. First, this electrification of IR network. Now, 97% of the network is already electrified. It is stated that in India, carbon emissions almost they get reduced by 55 to 65% once we switch over from diesel to electric. Of course, in the world, it is much higher because the dependence on renewable sources are more. But right now, it is 55 to 65%. So as on date, 97% of the territory is electrified. Maybe in a year, the balance also will be completed. Same in the case of Southern Railway also, 95% of the network is already electrified. In a year, we'll be completing the balance. And coming to GTK, share of GTKM also in Southern Railway, it is almost 97%. So 100% we are on electric, we are working the services on electrified traction. Next. Efficient use of electric traction. So with the increase of three-phase locos, EMUs, train sets, now a lot of energy efficiency has increased, and power factors, usage of power factor at TSS, especially the static power factor compensation and the dynamic. So power quality compensator, these also, they reduce the higher harmonics and reduces the energy demand. In Southern Railway also, which have built power factor management will almost maintain time. And further, this high harmonic we are suppressing. Still, we are having 47 already years works are in progress. In very short time, we'll complete this. This will improve the overall efficiency in utilization of electric energy. Next. HOG technology, of course, has taken place, including the Southern Railway. So a lot of reduction is reducing a lot of carbon. Now coming to the renewable energy sources, the scenario of wind power. So in IR, total as on date, 103 megawatts is installed. So it is producing 246 million units of electricity annually and cutting carbon emissions. In Southern Railway also, we have one 10.5 megawatt wind power installed in capex mode. It is almost saving 50, reducing a lot of carbon emissions. So further in Tamil Nadu, there is a lot of potential for wind power. And in the coming years also, we can have more plants. Of course, only the limitation is because there is no open access in Tamil Nadu, we cannot go for a developer mode. We have to go for only capex mode. Then only it can be done. Maybe we can think of proposing more works in capex because there is no open access. We have to depend on capex mode only. Next. Solar power. So in Indian Railways basis, land-based solar for 56 megawatt is already installed on date. Solar rooftop 203 megawatt is installed on date. In the case of Southern Railway, we are having solar rooftop at the moment 5.84 megawatt. Further, it is saving a lot of energy and cutting the carbon emissions. This, of course, it has two component developer mode also. Earlier, we could develop 3.98 megawatt and capex mode 1.67. But solar rooftop, now we are having works. Almost 50 megawatt, we are having the works. So partially it is developer mode 3 megawatt and 11.6 in capex mode. So in the next maybe 1 year, we can complete this. With this 15 megawatt will be commissioned. Then we'll be having totally 20 megawatt solar power. So only challenge in case of Southern Railway is we cannot now for whatever we develop, we cannot inject into the grid. There is no open access or there is no net metering. So we have to make a system so that we utilize whatever we develop. Maybe in many cases, non-traction loads may not be, there wherever we have solar rooftop. So we have to have a mechanism where we pump it to the traction grid. So that in the coming years, we have to, work on that. We have also identified land parcels in different divisions in Southern Railway. 258 acres of land is already identified. The Railway Board has given permission to install solar land based in developer mode. About 60 megawatt can be generated, but only challenge is again because there is no open access in Southern Railway, in Tamil Nadu especially. We have to have a way to pump into traction network. We cannot pump into the grid. That is the only challenge, but we'll work on that. But we will work towards installing this 60 megawatt. Next. Long-term open access. In all India scenario, wind power of capacity 82.4 megawatt is procured through long-term open access. This is applicable for the states where there is a open access. So solar solar power of 386 megawatt procured through long-term open access in the states where there is a open access. So further in 14 states where there is a open access, in fact, there is a big planning in borrowing this renewable energy through open access. So next 2-3 years, I think almost there is a plan to achieve 70% of the net zero carbon target. Southern Railway has filed short-term open access application after the Supreme Court order. Already, I think it is in advanced stage. We'll be able to get short-term open access. Then we can also start purchasing the green power in substations of Tamil Nadu. Next. So for the future, the main thing is the green energy, wherever it is possible to purchase through open access. Though in Tamil Nadu, it is not possible through long term. Short term, maybe we can try and get green energy. Install land-based solar in developer mode, wherever there are land parcels. In open access states, we can pump it to the grid. The states like Tamil Nadu, where there is nothing, we can feed into the traction network. We can develop systems in that line. So pumping rooftop solar into the traction network, wherever it cannot be consumed. It is very much applicable in the case of Southern Railway in Tamil Nadu state, where we don't have open access. Now it is a time we develop systems to, pump into our traction substations so that we can utilize whatever we get generated through solar rooftop, because almost we'll be having 20 megawatt, definitely will not be having traction loads. We have to have systems to feed into the traction network. We should also work in the field of building integrated solar power, because in Southern Railway, we are just in the beginning. In I think Chennai division and TVC, we have some contracts we are entering. So we have to work a lot on this, because once we start using this, because a lot of buildings, sheds, workshops, everywhere we can have BAPV systems, and we can generate a lot of solar power. Next. So install wind power where there is a scope. Especially in case of Tamil Nadu, there is a lot of potential, and we can work on the wind power. Install battery storage system, which we had the Delta Electronics has presented. Definitely, this is a future. Basically, we have to install the battery storage systems at TSS so that we can have peak energy management and improve the energy losses at substations by providing power quality compensator that we are already working in Southern Railway. So these are the things basically. With all these measures, maybe next few years we have to work a lot so that next 5 years we can make the railway net zero carbon emission. Thank you. Now I request. Now this is the end of the seminar. We are coming to the end of the seminar. I request Mr. Samir Dige, C projects, to give vote of thanks.
Good afternoon, everyone. It is a great honor for me to extend a heartfelt vote of thanks at the conclusion of this insightful seminar on the occasion of 100 years of electric traction. First and foremost, I would like to express my deepest gratitude to our respected General Manager for sparing his time and gracing this seminar. His presence has motivated the entire team and encouraged us to move forward in the right direction. I also thank all PHODs, DRM Chennai, and senior officers for attending the seminar. I sincerely thank our beloved Principal Chief Electrical Engineer, Shri Somesh Kumar Sir, for continuous guidance and support for conducting this seminar and also other events related to the celebration of 100 years of electric traction. I also thank all esteemed speakers for sharing their valuable insights during the seminar. A special thanks to CED Sir and organizing committee whose dedicated efforts made this seminar a great success. The meticulous planning and seamless execution ensured a smooth experience for all of us. I would also like to extend my appreciation to all the staff and supervisors of electrical, S&T, engineering, and all other departments who have worked behind the scene to make today's seminar successful. As we conclude, I hope that today's discussions will inspire us all to explore further advancements in railway technology and contribute towards a more efficient and sustainable railway system. Once again, thank you all.